Okay, that's not fun. But you did. At least you had a job. That's not a bad thing, I guess. You know, if you want a job, it's a good thing. Riley, how about you? Caught up on some sleep. Okay. Caitlin.
I went to a lake yesterday during the rain. It's kind of scary.
It was scary?
Yeah.
Why?
The wave, it was like way over flooded and the waves were very tall.
A little choppy, huh? A little choppy out there. Stacy, how was your weekend?
I hung out with friends.
Hung out with friends. That's good to do always. That's good. Noah? Hung out with friends. Ty?
Hung out with friends.
Man, a lot of friend hanging out. I like that. Sam? There's a theme going on here. My goodness. Geiger? Grace?
I walked my dog.
Walked your dog. Does your dog like going out on training?
Yeah, but we don't really let him because he just gets too wet.
Gets all gross?
Yeah.
I have two labs. One loves to go out in the rain, and the other one absolutely hates it. Hates it. Loves to swim in the water, but hates the rain for some reason. I don't know what's up with that. Owen. Oh boy. So the dog's at your house? At least you don't have to go over to her house to take care of the dog. That would be a pain. Big pain. Mr. Wright.
I spent all day Sunday procrastinating homework, but like by the end of the day, I just realized I didn't even have any.
Oh, well, see? You ruined your day avoiding the stuff that didn't even exist. Yeah, all right. Great. How'd they do? Oh, man. Krista, where'd you go? Was this Saturday? So it wasn't muddy then. Good. Hung out with friends. Alexandria. Hung out with friends too. My goodness. So, but everything's working now? That's it. There you go. All right. Great. Well, let us go ahead and jump in here and get going and see what's going on, what we're going to be working on in here. What are we going to be working on that would be familiar to you from Algebra 1? What could it be, I wonder? Well, let's go ahead and find out. Arithmetic and geometric sequences and series. So just from the heading, does this like even like sound remotely like anything you remember? Yes. You remember both arithmetic and geometric? No, just arithmetic maybe? What about the words sequences and series? Do those like ring any bells? Does sequence make any? What about series? No. So maybe a little bit, some of it you did do, and some maybe did not happen. And we'll find out about that. This is one of those where I've actually created a packet of fun where you can take your notes. And some of this is already written there. Makes it easy to get through more on this first day. Totally paid for already. These copies right out of my paycheck, every copy I make. Not really. I don't. Should do. Woo! Now okay. So we're going to go through this today, get through this, and actually on here your assignments at the very end too, so that's kind of nice. Everything's included on here, which is great. Arithmetic and geometric sequences and series. So here we go. We're going to jump right into this. There's two different parts of this. There's the arithmetic part of it and the geometric part of it. We're going to start with what's arithmetic mean, okay? So we're starting with arithmetic sequence, okay? So a sequence. Now, first of all, a sequence is nothing more than a strand or a bunch of terms, okay? And for us, usually they're numbers. They don't have to be numbers. You could have letters that are sequences. But they are terms, okay, that are related to each other somehow, okay? They're related to each other somehow. So here I have 4 numbers, and you notice that it goes dot, dot, dot. Those numbers are related to each other somehow, okay? So it's a sequence where the difference between consecutive terms is constant. It is a sequence where the difference between consecutive terms is constant. It is referred to as the common difference. So here I have these values. Now, first of all, this is considered the first term, okay? That is the first term. This would be the second term, third term, and fourth term, all right? Now, a couple things you have to understand before we go any further. I could write down that the first term, I would write this, okay? This down here tells me it's the first term. This little subscript number does. So if I want to write down the second term, it would be a sub 2 equals 7. And then a sub 3 equals 15. And a sub 4 equals 23. Okay? So the term is this little subscript value down here. And then this is the value in the sequence itself. Okay? All right. So we're looking at this, and it says that it is a sequence where the difference between consecutive terms is constant. So let's look at this. What is the difference between these two consecutive terms? 8. It's 8. Yep. What is the difference between these two consecutive terms? 8. And these, of course, is 8. So you can see that it is a constant consecutive term. It's a constant difference between consecutive terms. This is known as the common difference, and we just label it as D. So here, D is 8. Boom. That means if I wanted to find the fifth term, all I would do is what? Add 8 to the number 23. So if I wanted it, the next one would be 31, and then it would be 39. I can keep going, blah, 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 right? It goes without ending. It just keeps on going. Okay, boom. So arithmetic means that the terms have a common difference between them. It's always going to be the same amount if you go up every time. Okay? That's easy enough. That doesn't seem too bad. Yeah. What do you mean? Ignore it. -1 plus 8 would be the 7, right?
Yeah.
Yeah, and then 7 plus 8, 15. 15 plus 8, 23. Yep, it's okay. All right. Now, here's the thing. So these term values will always be positive for us. The term is. The value in the term could be positive or negative. So these values here will always be positive, and these values here can be positive or negative. And they don't have to be whole numbers. They could be any number. They could be fractions if I want them to be. It could be anything I want. Okay? All right. Again, arithmetic sequence. Oh. So I guess the first thing we should do is just, hey, tell me on your sheet, I want you to look at these and tell me if these are arithmetic sequences or not. You're just going to check these 3. I've given you 3 strands of numbers. Your job is to see, are they an arithmetic sequence? That's all you're going to do. And if it is, you're going to write down what the common difference is. That's the first thing we're going to do. Is it arithmetic sequence? If it is, what's the common difference? We're doing that for a minute. Shoot. Click here. Everybody's here today. That's great. Right? Gobbledygoos. All right. Come on. A little bit faster, a little bit faster. Okay. Beautiful. All right. So, first one up here, yes or no? Is the first one arithmetic sequence? Yes, it is. Okay, so if it's an arithmetic sequence, the value of D for the first one is how much? 5. Boom. End of story. Great. All right. Second one, is it arithmetic or not? No, it's not. How do I know it's not? If you were going to explain to somebody why it's not arithmetic, how would you be able to explain that to them?
It's not a constant common difference.
Yeah, there's not a constant common difference, because here between these two you do what? Plus 2, and then you go up, and then you go up. Yeah, so that's not a common difference. So no, that's not arithmetic. Okay. Last one. Yes, it is. And the common difference here is -3. Okay. So the common difference could be an addition or a subtraction. It could be a positive or a negative. All right. Great. So that's what an arithmetic sequence is. Okay. Now, what if all of a sudden I said to you, okay, like on this last one down here, what's the third term in this sequence on the bottom? 11, right? All you have to do is look at it and say, oh, yeah, it's 11. I can see it right there. What if I asked you for the 80th term? Then you go, what? Right? You don't want to go ahead and find all those, do you? You don't want to go ahead and say, okay, Mr. Schneider wants the 80th term, so I'm going to have to go ahead and make an entire, I'm just going to keep going. There better be a different or more efficient manner in doing that. Let's see here. So let's look at this. Oh my goodness, to write the rule for the nth term. To write the rule for the nth term of an arithmetic sequence, use the form, there's nothing there. Okay, here we go. Now, look what this is saying. It says a sub n. So the nth term of the sequence is equal to the first term plus n minus 1 times d, which is called the common difference. All right? This would be how you can find the rule for the nth term. So we're going to try it with this one right here. The first thing I need, of course, is what? The common difference, okay? So the common difference here is going to be what? Okay, so here the common difference is -3. Boom, got it. So I have this, check. Okay, I told you I wanted the what term? I'm going to want the 80th in a second. We're not going to find it yet. I want the rule. What else do I need? The first term, do I have it? Yeah, it's right here. Check. So I can write my rule right now. I can just write it. It's going to be a sub n equals 17 plus n minus 1 times what? -3. Now, in all actuality, you could just leave it like that if you wanted to. You could. It's true. Is it simplified? No, it's not simplified, is it? I mean, if I asked you to simplify that, you could do what? What could you do first if you wanted to simplify this? Huh? Distribute. I heard somebody say distribute. Right? You distribute this through. Let's just do this real fast. A sub n equals 17. What would happen here? What would I get? -3n plus 3. And if I kept going with this, I would get a sub n equals -3n plus 20, or if you said 20 minus 3n, that would be the exact same thing, right? They're the same, right? look like anything you don't want? Does any of this look like something you should recognize?
Yeah.
I hear, yeah. Why? It's what? It's a linear equation. Doesn't this kind of look right here? Doesn't this kind of look like y equals mx plus b? Doesn't that? Where the common difference is the same as the what? Rate of change. It's how it's changing every time. So when we talk about sequences, we call it the common difference. When we're in a function, we talk about it as the rate of change. So how do these things differ? Why don't we just not say that why is an arithmetic sequence, why don't we just call it a linear sequence, I guess, is the question. Well, because they're not exactly the same. On a linear function, the domain is all real numbers. All real numbers. Okay? On an arithmetic sequence, it's not true. The domain is not all real numbers. The domain is usually all the counting numbers. 0, 1, 2, 3, 4, 5. In other words, the domain never has a fraction. It never has a decimal. It's integers. It's positive. It's 0 and positive integers on a sequence. But on a linear function, you could put in x equals 1/2 if you wanted to. You would never do that on arithmetic because there's no such thing as a half term. You can't have that. You only talk about full terms. All right? So they're the same, but they are different. Same, but different. Okay. By the way, does anybody recognize what this is for a linear function? What is that? I'm going to rearrange it. Guess what this looks like? You guys saw it like this. Anybody see this in algebra? What's that called? Point slope form. If you bring that y over to the other side, you get this. That is point slope form. That's all it is. It's point slope form. Okay? Now you don't have to worry about that. I don't care about that. I'm just throwing that out there for you. Okay? Great. So if I give you a sequence, I could say, is it arithmetic? If it is, write a rule for the nth term of the sequence. So here it is. We checked it. It is. Boom. We write the nth term. And then I could say find any term I want. So now maybe I say find a sub 80. So all I do is what? I plug 80 in either here, or here, or here, or I plug it in any of those I want. It doesn't matter. They're all the same. They're equivalent. So I would plug 80 in. Let's just plug it in right here. That would be 17 plus 80 minus 1, which is what? 79 times -3. It's a lot. This is going to be a lot quicker than doing what? Counting out over and over again if you just got a calculator right now, right? We can do this in our head, right? This is going to be negative. This is going to be 27. What? -237. Is that right? Oh, look how nice that is. What do you get? What's the 80th term going to be? -220. Boom. Done it. Got it. Okay. So an arithmetic sequence. It's nothing more than a linear function where the domain is 0 and positive integers. Okay? Just think of it that way. It's okay. It's all right. All right. Woo! Guess what? Any questions yet? Let's go. Let's move on. Here we go. So I just gave you one where I gave you a sequence and I asked you to write the rule for the nth term. Let's change this up a little bit. Here we go. Can we write a rule for an arithmetic sequence if we're given the common difference in any term? Let's try this. Okay? So this time I'm telling you I want a sequence. I want to be able to generate a sequence where the common difference is always -7 and the 11th term is -57. All right? Now, remember what our thing we just did was. I had the a from the previous slide, I had a sub n was equal to, what was here? A sub 1 plus parentheses n minus 1 times d. All right, now here's the thing. I want everyone to pay attention to this. This number here and this number here have to be the same. They have to be the same. Okay? So if I'm doing the 11th term, my a sub n would be a sub 11 plus n minus 11 times d. It just changes. It just changes to that. That's all I have to do. Okay? So for this one, a sub n would equal -57 plus n minus 11 times d is -7. Now I'm going to simplify this, of course. I like it to be simplified a little bit. A sub n equals -57 minus 7n plus 77. What is that going to give me? A sub n equals, come on guys, you got this, -7n, if I write it like this, plus 20. Okay, now, could I give the first term if I wanted? If I wanted the first term, what would I plug in for n? 1. So what's the first term? 13. If I wanted the second term, I'd plug in 2 for n. If I wanted the third term, I'd plug. That's all I have to do. Notice again what I said. This and this are the same. Okay? Those values are the same. So it doesn't matter what term I give you. I can always write my rule like this. It's easy enough. We got that. Questions on that one? Does any of that look familiar? Maybe? Maybe not? We'll see. Okay, here we go. Let's change it up again. Well, we got through that. Hey, what if I give you 2 terms of a known arithmetic sequence and you have to write the rule? I give you 2 terms. Now, guess what? If I'm giving you 2 terms, guess what I'm giving you, really? Remember, we said this is kind of like a what? Linear function. Yeah. It's like giving you 2 points. Guess what point this is? 726. Guess what point that is? Yeah, 1671. If I gave you 2 points and asked you to write a linear function, what's the first step? Find the rate of change slope. That's the same as the what? Common difference. So if I'm going to find the common difference, I just have to think about, oh, I'm finding the slope, because that's all it is. So if I want to, I'm just calling it the common difference. D is equal to what? 71 minus 26 over 16 minus 7. Change in y over the change of x. Boom. 71 minus 26. Woo. 71 minus 26. Has anybody got that one for me? 45 over 9. Common difference is 5. All right. So now I have the common difference. Now I want to write the rule. Okay, so let's think about this. How many choices do I have for this value here? 2. I could either use 26 or 71. If I put 26 in here, what has to go over there? 7. If I put 71 in here, I'd put what there? 16. When I simplify them, they better be the exact same. So I can either do this one or I could do this one. But either one of those better simplify down to the exact same thing. So we'll just do the top one here. Let's do this. We'll do them both. Let's do that one first. That's going to be a sub n equals 26 plus 5n minus 35. A sub n equals 5n minus 9. Okay, let's see if the other one gives me the exact same thing. Here we go. Now we'll do this dude right here. A sub n equals 71. I don't know why I put an equal sign there. Woo. Okay. 71 plus 5n minus, what do I get there? 80. Same. Doesn't matter. Okay? So if you can work with linear functions, you can do this. It's kind of a specialized linear function with a rate of change. Boom. There it is. X values are always going to be integers. Okay. Any questions at this point? All right. Here we go. So this the first slide of this thing today said arithmetic sequences, arithmetic and geometric sequences and series. Now we're talking about what a series is. Okay, so here we go. Arithmetic series. This is what we're talking about now. It is, so the series finds the sum, which means we're going to do what? Add up. It's the sum of a finite or infinite number of the terms of an arithmetic sequence. Now, for us in here, we are going to be dealing with finite. That means that it ends, right? So I'm going to tell you, I want to find the sum of so many terms of an arithmetic sequence, and that is then called an arithmetic series. Okay? To find the sum of the first n terms of an arithmetic sequence, this is called a finite series. Has a beginning and an end. Okay? You can use the formula. There it is. Okay. S sub n equals n times a sub 1 plus a sub n over 2. All right? Now, what does that mean? Well, where S sub n is the mean of the first and nth terms. Right here. See this? You take the first term plus the last term you're going to use. You add them up and divide by 2. When you take two numbers and add them up and divide by 2, you're finding their average. You're finding their mean. Okay? So it's the mean or the average of the first and last term multiplied by the number of terms you're going to add together. The number of terms you're going to add together in this series. All right? So the best way to look at this is right below it, you have an example problem. Right below it, you have an example problem. This one, okay? So given the sequence, write a rule for the nth term, then we're going to find S sub 8. We're going to find the sum of the first 8 terms, okay? So would everybody please do this? I want you to start by finding the rule for the nth term. That's review the first so many slides. And then we're going to try that formula for this as well. Okay? So would everyone try that problem right now? While you're doing that, I need to check this. All right. Beautiful. Beautiful. So let's start with the rule. Let's start with the rule for this one. Just curious how we did. So a sub n equals, since I gave you the first term, you could just use that. Would just be what? 5 plus n minus 1 times, what's the common difference here, by the way? 4. Okay, boom, there it is. So we could simplify this to be 5 plus 4n minus 4. So it looks like a sub n is what? 4n plus 1. Boom, got it. Okay, great, got it. Now I want to find the sum of the first 8 terms I said. All right. So the formula on that you have above it on your piece of paper, this piece right here, S sub 8. So this is the sum of the first 8 terms of this sequence. Okay. What goes here? 8. It's the how many terms I'm adding together times the first term, 5, plus the 8th term, whatever this is here, the 8th term. So 1, 2, 3, 4, 5, 6, 7, 8, 33, divided by 2. Oop. So this would give me 8 times, this is going to give me 38 over 2, which is 8 times 19, right? Which is 152. So S sub 8, the sum of the first 8 terms is 152. This right here is referred to as the 8th partial sum. It's another way of saying this. When you find the sum of a finite number of things, it is called a partial sum. Because you're not finding the sum of all the values, it's just a piece of it. It's a part of it. So this could be, I might say, hey, find the 8th partial sum. This is the 8th partial sum. That's the same thing. So if I said find the 12th partial sum, you'd have to go ahead and find the sum of the first 12 terms in the sequence. All right? So if you generalize it, if you have this, this is the nth partial sum is another way of referring to this. It's called the nth partial sum. All right. Boom, 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 boom. All righty. I like that. That's good. So here we go. Let's do this. You ready? So here's a word problem. This is a word problem. All right. Look what we got. House of cards. Anybody ever build a house of cards? Yeah. I used to do it. We used to do it just for the fun of it, just see how far we could go. It says write a rule for the number of cards in the nth row if the top row is row 1. The top row is row 1, not the bottom, the top is. So first we have to do is write a rule, and then it says what is the total number of cards if the house of cards has 14 rows? Oh, all right. Here we go. So let's write down the terms of our sequence. What is a sub n? Or what's a sub 1 equal in this problem? 3. It's the number of cards in the first row. A sub 2 equals what? 6. A sub 3 equals 9. Okay, great. So these are the first 3 terms in my sequence. What is D?
3.
Yeah, plus 3. Beautiful. Got it. All right. So let's write our rule down. It's going to be what? A sub n equals first term 3 plus n minus 1 times 3. And I can simplify it. A sub n equals 3n what? Minus 3 plus 3, which is what? Plus 0. Do I have to put it? Nope, it's right there. Boom. All right. So that's part A. Ciao. Okay. Part B. Total number of cards at the house of cards has 14 rows. Do I need to find the first 14 terms? Oh, when you come back, we'll keep going. When you come back, we'll keep going. What? So we found the rule for the nth term. Now we're trying to find this, which would be the 14th partial sum. So I want to find that. So what do? I take 14 times first term, 3, plus I need the 14th term. How do I get it? I plug in 14 here. So what is 3 times 14? What's that?
42.
42. Yeah. Whoop. Divide by 2. Finish it up. Now, when you're doing this, I'm going to just do this with you. This is 14 times. This gives me what? 45 over 2. Do I have to do 45 divided by 2 first? Could I do this if I wanted? Is this okay? Is that okay to do that? Seven times 45? What did I do? I did what do you call that when you're multiplying fractions and you reduce these numbers instead? Probably was called cross reducing is what you called it, if you even talked about it. Because like I can reduce these instead. This 2 times 1, just put the 2 here. Oh, 7 times 45. I can do this in my head now. 7 times 5, 35, carry my 3, 28, 3, 315. If I look at them, I can probably do them somewhat in my head if I think through them. Great, you got it. How many decks of cards did you need then? Snyder, you're funny. How many decks, how many cards are in a deck?
52.
52 if you're not counting the jokers, right? Yes, he did a little bit more than 6. You probably have to have at least 7 if you want to do this. Okay. All right, there you go. Boom. Boom, boom. How many of you do used to have Wii's? Anybody have Wii's? How many of you had like the resort Wii? And did you guys ever do the bowling where it had all of those pins? It wasn't just 10 pins, it was like 100 pins? Yeah, it was arithmetic, right? 1, 2, 3, 4. You could figure it out. Boom, you could figure out how many pins were there. All that great stuff. Okay, great. Anyways, I love that game. I love Wii bowling. So simple, but so much fun. And then how many of you were able to do that last ball on the 100 pin where you get it up on the side rail and get it to go down and hit the button? That was like such a challenge. You know, I love it. All right. So anybody have any questions on anything up to this point? This is your chance before we go to geometric. We're going to switch gears to geometric now. Nope. All right, here we go. Woo! Geometric. So now we're going to talk about what a geometric sequence is. So now we're still dealing with a string of numbers for us, okay? Now we have a sequence where the ratio of any 2 consecutive terms is constant. So it's not a common difference, it's a common ratio between consecutive terms. The constant ratio is called the common ratio and is denoted by the letter R, okay? So I've got 2 examples here. If I look at this one and I want to find the common ratio, it's always a term divided by the previous term. So this would be 6 over 2, which is 3. This would be 18 over 6, which is 3. This would be 54 over 18, which is 3. Okay? So here, on the first one, R is 3. That's the common ratio. Second one over here. Here we go. Negative 6 over 3, negative 2. 12 over negative 6, negative 2. Negative 24 over 12, negative 2. So here R is negative 2. All right. So that means I can call this these are geometric sequences because they have a common ratio. All righty? They have a common ratio. So what does that mean? On the last one, you can add that number to go from term to term. Here, you don't add by that number. You do what?
Multiply.
Multiply. 2 times 3 is 6, times 3, times 3. Here, times negative 2, times negative 2, times negative 2. That's all it is. It's what you multiply by over and over again on this one. Common ratio. So here you go, check them. Yes, no, if it is, give me the common ratio. This over here. Okay. Oops. Click. All right. So, first one, yes, no?
Yes.
Yes, it is. What's R equal? 1/3. So your ratio doesn't have to be a whole number. It could be a fraction. Okay, it could be a fraction. Second one, new. Last one.
Yeah.
Yes, it is. Common ratio is? Yep, negative. So now we can identify geometric, if it's geometric or not. By the way, is the second one arithmetic by any chance? No. Does not have a, so it's neither. It's not geometric and it's not arithmetic. It's neither one. It's still a sequence right now, but it's not arithmetic or geometric. All right. Woo. So kind of like the last time, our goals are going to be the same. Being able to write a rule for the nth term of geometric given different information. And then we're going to be dealing with geometric series after that. So here it is. We want to be able to find the nth term, a rule for the nth term of a known geometric sequence. It's pretty easy. Here we go. There it is. Okay, so we look at it. A sub n equals a sub 1 times r to the n minus 1. A sub 1 times r to the n minus 1. All right. So I need the first term, and I need the common ratio in order to write the rule for the nth term. We can do that. We're skilled. You got this. So I already know the first term. There's a sub 1. A sub 1 is 3. R here is going to be 5. So it looks to me like the rule for this would be a sub n equals 3 times 5 to the n minus 1. Now let's just see if it works. This is the what term? This is where n equals 3 then. Great. So if I plug that in, 3 times 5 to the 3 minus 1 would be 3 times 5 squared, which is 3 times 25, which indeed is what? 75. So it works. Okay? Works. Beautiful. Love it.
Why did you choose the third one?
I just chose one of them I had to see if it worked or not. I could have chosen the fourth one to see if it worked in there or not.
Okay.
Doesn't matter. So now we can write a rule for the geometric sequence if we have the first term and we can find the common ratio. Easy enough. Of course, it's just like the other ones. You may not always know the first term. Okay, you may not know the first term. So what would be the next option? Well, here we go. This time I've given you the common ratio and I've given you the sixth term. I've given you the sixth term. Now let's think about what that equation I gave you before was a sub n is a sub 1 times r to the n minus 1. This and this will always be the same. They're always going to be the same. Okay. All right, so let's look at this one then. On this one, I don't have the first term, I have the sixth term. Okay, I have the sixth term. So how am I going to do this problem? Well, if I did this, I put a sub n equals what? Negative 96 times 2 to the n minus 6. Now, here's a question for you though. On the previous ones, the arithmetic, I could take all of those and simplify them so they all look the same at the end, right? We always could simplify them and make them look the same. What about this? How in the world am I going to do that on this one? Because I really would like to write it maybe different than this. I mean, this would work, but is there anything else I could do on this problem, I wonder? Yeah. Logarithms, wow. I could, but here's what I'm going to do. What I really would like to know is what the first term is somehow. That's what I really would like to know. All right, you ready? Here we go. It's all right here. A sub n is a sub 6 in this problem, which is negative 96. So guess what goes over here? Negative 96. Guess what goes in place of n up here? What is n? 6 minus 1. We're going to solve for the first term. So what we literally did is we plugged this goes in place of a sub n. This value of 6 goes in place of n here so we can find the first term. So we're going to solve this. All right? So now I get negative 96 equals, and r for us was what? 2. So it's a sub 1 times 2 to the 5th power. So the first term is whatever negative 96 divided by 2 to the 5th power is. That's going to be the first term. So it's a little bit different as far as what we did in the previous one. I have to find the first term on this one by plugging in the term I know. Okay? 2 to the 5th.
32.
32. So it's negative 96 divided by 32, which is negative 3. That's the first term. Boom. This is the first term right here. Now I can write my rule. So for this, it would be a sub n equals negative 3 times 2 to the n minus 1. There it is. Okay. Anybody want to ask anything on that one? Take this one off and switch it to blue.
Why are we allowed to put negative 96 in place of a of n?
Say that again.
Why are we allowed to put negative 96 in place of a
Well,
sub n?
so what I'm doing is on this problem up here, what I'm going to do is let n equal 6.
Okay.
So then if n is 6, a sub 6 is what? Negative 96. All I'm doing is saying I'm going to use that as a point.
Okay.
This is nothing more than the point 6 negative 96 is what that really is. Okay. All right. Anybody else? So that was giving you the ratio and some random term in a known geometric sequence. Guess what's next? Boom, this one. Yep, I didn't give you the common ratio, and I've given you what? 2 different terms. I've given you the second term and the fourth term. Okay. Okay. Wow, what in the world am I going to do here? I have to find the what? Common ratio. Now, I want everyone to think about this. Okay. The common ratio is whatever you're going to do, and you're going to multiply by it, right? Oop, I put a 3 there. Times R, times R, times R, times R, right? That's what's going on. That's what the common ratio is. It's what you multiply to go from one term to the next term. This term right here is negative 12. And this term is negative 3. So let's think about this. And here is a sub 3 in between them. Can anybody give me something I could do here? I want you to think about what can I do with that? How'd you get that? Just did it in your head, okay? You might be able to do it in your head sometimes, that's true. Let me ask you this. How do you find the common ratio? How did we find the common ratio before? What's that?
You plug the points in.
Yeah, how did I find the common ratio back here? What did we do to find the common ratio? We took a term divided by the what?
The term before it.
Yeah, the term before it, the previous term. That's how we found the common ratio, right? 27 over 81 is 1/3. I don't have consecutive terms, but I can still use the same thought. Negative 3 divided by negative 12. Now, guess what? That's not the common ratio. That's how many common ratios? 2. R times R is R squared. So what this is equal to R squared. That's what that really is. Oh, so R squared equals 1/4. Negative 3 over negative 12 is 1/4. Take the square root. What's R equal? What's R equal? Yep, guess what? It equals positive and negative 1/2. Uh-oh, guess what? There's 2 possibilities for this. There are 2 possibilities. I don't know. R could be positive or R could be negative, and it will work. If I took this times the positive 1/2, I'd get what? Negative 6, and then I get what? Negative 3. What if I took it times the negative 1/2? What would I get? Positive 6, and then that times the negative 1/2 would give me what? So it could be either or. I have to write a rule for each possibility then. So it's going to have 2 rules on this particular problem. There are 2 different rules. All right, now, to make my life easier, guys, to go this direction, it's times either positive or negative 1/2, either one. What would it be to go this direction then? Divide by 1/2, which is the same as multiplying by. So what are the possibilities for this first term? What is my first term going to be? If it's the positive, it's going to be negative 24, or maybe it is positive 24. So now let's write our rules. Are you ready? We're going to write them. Rule 1. And we're going to do rule 1 where R is positive 1/2. All right, so what would it be? It'd be a sub n equals, which of these would be, if R is positive 1/2, what's going to be here? Which number? The negative 24. So it'd be negative 24 times 1/2 raised to the n minus 1. The second rule would be if r is negative 1/2. Rule number 2. But this time, the first term wouldn't be negative 24, it would be positive 24. And both of those work for this and for this if you plug them in. All right? Oh, yeah. Oh, yeah. So now this is a little different than the arithmetic. It's just one possibility. Geometric, you might get 2. Not always, sometimes. Sometimes you will have to write 2 rules. So why did I have to write 2 rules here? What made me have to write 2 rules? I had a positive and a negative what? R value. Okay? And so in other words, if I have 2 possibilities for R, then I have 2 possibilities for my rule. What is going to make me know if my rule is going to have 2 different values of R? It's going to be R to what kind of a number? What's that? Even. Because what happens when you take even roots? You have positive and negative roots. If I had given you a sub 2 and a sub 5, and I had given you a jump of r cubed, you would only have 1 possibility. So geometrics don't always have 2. Okay, it's dependent upon what information were you given. Okay, what information were you given? Okay, so this one had 2. Oh boy. We're going. We're doing good, guys. We're going to be practicing this stuff. Don't worry. We're trying to get through most of it today, so tomorrow we can practice it. All right. So now we're going to talk about a geometric series. Okay, so an arithmetic series was the sum of terms in an arithmetic sequence. Geometric series is the sum of the terms in a geometric sequence. Okay. Again, it could be finite or infinite. For us, we're going to be dealing with just the finite, a set number of terms. To find the sum of the first n terms of a geometric series with a common ratio where r does not equal 1. So the common ratio is not going to equal 1. Here we go. Looks a lot worse than the last one, I'm sure. Okay? So look what we got here. S of n, or the nth, is still called the nth partial sum. Okay? So the sum of the first n terms is equal to first term, a sub 1, times 1 minus r to the n over 1 minus r. Now that n is only being applied to this value of r right here. Okay? That n is not outside the parentheses. It's because if it was, it would just be the value of 1 to the nth, which is 1. That's pointless. So that n is only going with this value of r right here. Okay? All right. Now the best way to do this is just to do one, to try it. So I've got a sequence here. Okay, this one was nice because I've given you the first term in the sequence. So in this particular problem, a sub 1 I already know is negative 1. And for us, r is going to equal what? What does r equal in this problem? Negative 2. All right, great. So we're going to go ahead and we're going to find the sum of the first 6 terms. So I'm asking, we're going to find s sub 6. Okay, or the 6th partial sum. All right, here we go. So it's first term, negative 1, times 1 minus r is negative 2 to the what power? 6th power over 1 minus negative 2. So this is negative 1 times, okay, what am I going to get in the numerator? 1 minus what? What is negative 2 to the 6th power? Negative 2 to the 6th power. Is that going to be a positive or a negative number? Positive. And it's going to be positive what? So it's 1 minus 64 over what? 1 minus negative 2, which is 3. That is negative 1 times, what is 1 minus 64? Negative 63 over 3. Okay, let's keep going. What am I going to get here? What's the inside? What's negative 63 divided by 3? Yep, so it's negative 1 times negative 21, which is, there it is, 21. S sub 6 equals 21. Okay. Now, this kind of a problem is not that bad unless the common ratio is not an integer, but is a fraction, like 1/2. Because then what would happen? Then you get 1 minus some fraction over 1 minus some fraction, which means you get a fraction over a fraction, which you guys just love fractions. Okay? So there's the 6th partial sum. How are we feeling? Is that a little bit harder? Probably. It probably could be. The geometric ones in general are a little bit more complicated. Now, I haven't asked this yet. I'm going to come back to this slide in a second. But we said arithmetic was kind of like what kind of function? Linear. So what's a geometric kind of like? Exponential. Now, if you ever hear somebody tell you that geometric is exponential, tell them it's not, please. Okay? Arithmetic is a special type of linear function. It's a linear function where you only use the domain of 0 to infinity with integers. That's it. So it is a special linear function. Geometric is not an exponential function at all. And the reason it's not is because in an exponential function, the value of b, the base, is never allowed to be negative by definition. On an exponential function, the value of b, a times b to the b, the base, cannot be negative. But in a geometric, it can be positive or negative. So that's why it's not considered an exponential function at all. It kind of acts like one, but it's not. So if you hear some honors algebra 2 can say, oh, it's exponential, tell him he's wrong. Tell him he's wrong. Tell him to go back to his class. Say, you're wrong. Get away from me. All right. Woo, here we go. We did that. Let's do an example problem. So here's an example of geometric. Skydiving. In a skydiving formation with R rings, each ring after the first has twice as many skydivers as the preceding ring. So the formation for R equals 2 is shown. So this has 2 rings, okay? Let A sub n be the number of skydivers in the nth ring. Find a rule for A sub n. So we're looking at this. So the first ring, A sub 1, is 1, 2, 3, 4, 5. And the second ring is, of course, what? 10. So we know that R is what? 2. So we can write our rule right here. A sub n equals first term 5 times what? Common ratio 2 raised to the n minus 1. Got it. Done. So that's just plugging in the information. Okay? The second part of this question says, hey, how many total skydivers would there be if there was R was 4 rings? Now that means I'm finding what? The sum of the first 4 terms. Okay? So this would be, now if we're going to use the formula, what goes out here? The first term, which is 5 times 1 minus what? 2 to the, what goes up here? 4 over 1 minus 2. Okay, what am I going to get in the numerator? 1 minus
No, 16.
1 minus 16 over 1 minus 2, which is 5 times, in the numerator, it's going to be negative 15 over, that's a negative 15, Snyder, over what? Negative 1, which is going to give me 5 times 15, which is 75. There'd be 75 in there. Now, if you were getting a fraction back, you'd just say, I don't think that's happening. You don't want some fraction of a skydiver. That means you just have their parachute and they're gone. That's bad. Okay? Now, let's just real quick make sure. So this first string will be 5, then 10, right? Then what would be the next string? 20, and then 40. 40 and 20 is 60, 70, 75. Boom. I could do that in my head if I wanted to. I really could just do that one almost in my head. If I know that the second ring is 10, the next ring will be 20, and the fourth ring will be 40, because I'm just doubling each time I go out. So 60, 75, boom. I can see it's right. So if I gave you a problem like this, do you have to use this formula? If you did it like this, I'd be fine with it. I don't care. As long as you understand that a series means I want the sum of all of them. That's what you have to understand. All right. What time we got here? This class ends at
Oh,
9. Okay, so now I wrote this down and then I crossed up a few problems because I decided that's too many. Okay. And for you guys, since I know you don't have your books in here, just relax. Just relax the rest of the period. Don't freak out because I'm not going to scan them and post these right now. So these are the assignment, and you have this already, so you don't have to write it down. Okay, so you can see hopefully on there, I got rid of 14, I got rid of 24, I got rid of 32, I got rid of 16. I was a little bit kind of crazy when I was giving you numbers, okay? We will go ahead tomorrow, when you first come in, I'll put the answers on the board. We'll go over those, and then we're just going to practice working with arithmetic and geometric sequences and series. That is all we're going to do tomorrow. We're not doing anything new tomorrow. All right? If you have questions, get them ready tomorrow when you come in. We'll be good to go. And we got a lot done today, actually. That was good. We will be doing geometric sequences and series, I can just right now, this week, and then next week we'll have a test on it. And then that takes us to spring break. And then after spring break, you're going to need to bring back the Algebra 2 textbook. So I'm going to give you your pre-calc book, and we're going to start doing trig in here, which is what we need to be doing, okay? For calculus, you've got to get through the trig. And when I say the trig, it's the idea of right triangle trigonometry that you guys are used to, sine, cosine, tangent, but we will go further than that. And there's a lot you're going to have to be able to do with trig, okay? And we have to get through that in this class. We must. And there's not just a little bit. There's a ton that goes with it, okay? So we'll be doing trig starting after spring break. We will do, depending on how that goes, we will do either what are known as polar, parametric, or vectors. Those are 3 options I have I could work with as well. And then one thing we have to do also before the end of the year is what's known as limits. And that goes along with rational functions. And that will be the very last thing we do in this class. Okay? So we don't have, when you think about it, we really don't have a ton of time. We only have 9 weeks. 9 weeks, I'm sorry, not 9 weeks. We have 11 weeks. Is that right? 11 weeks. We have 2 weeks here, and then we have the 4 weeks after spring break. Okay? And the last week is exam week, if we're having exams. We haven't heard anything other than we are. So we really have 10 weeks then of material. All right? That's not a lot considering it's what, 4 days a week. So that's more like 8 weeks of material when you start thinking about it, right? 4 times 10 is 40, divided by normal 5, that's like 8 weeks. We have a lot we're going to be trying to get done in 8 weeks. I can tell you that right now. Yes?
You said spring break is in 2 weeks.
It starts on the 13th. So that 12th that you guys don't come to school because we're getting our second vaccines, that Friday, your spring break will start on that Friday, basically. So you're gonna get an extra day off because we're not assigning anything on that day, if I recall right. It's a non-school day for you guys. Okay. All right. Boom. ACT tomorrow. Good luck on that. Okay. Make sure you got your Chromebooks ready to go tomorrow for that. And yeah, there you go.
If we're taking the ACT, do you want us to look at the YouTube thing or whatever?
Well, tomorrow you can. It won't be all period because we're going to be doing a lot of just working on your own and getting help. And we might do some problems in class. So you can watch it if you want. Yes. Let's say you should swing by at some point. Can you swing by and just grab the work? It's going to be at the worksheet. Or I'll post it. I have to post it online anyways.
Like tomorrow?
I have to post it online for my online kids anyways. So you can either look at it online, or if you can swing by and get a hard copy of it, you can do that as well if you want.
Yeah, let's do it.
Yeah, it's whatever way you want to do, it's fine. Doesn't matter. Okay. All right. Wow. What a great day. I can stop this. Who's going out of town on spring break? Anybody? A couple of you, where are you going?
Colorado.
Colorado. You're going to skiing?
Yo, yeah.
Wow.
We were going to
Gatlinburg, cool.
California.
California, Southern,
Um,
San Diego, Los Angeles, north further, San Francisco, Oakland.
the Mojave Desert.
Oh my goodness. That'll be fun. How cool is that? You guys are